So since we're looking at transformations, let's just look through the different ways the values of a, k, d, and c affect the base graph of your function. And so I kept the variables the same as what you saw in the trig unit. And what really matters, it doesn't matter what letter you use for your transformations. Essentially what matters the most is where those values are located in the equation of the function. So here's the general function. It's not specifically linear, quadratic, exponential. It's just a base function of any sort. And what you'll notice is we have the variables a, k, d, and c applying different transformations to the base function. Okay? A, as usual, represents our vertical stretch or compression. And if it's negative, it's a reflection in the x-axis. So again, you'll notice that this value here is outside of where the x is. That's how I know it's a vertical transformation. So A is your vertical stretch, compression, or reflection. You'll notice that the next variable, which is k, is inside the brackets where the variable x is as well. So this indicates to me that this is a horizontal transformation of some sort. And because it's a value that's being multiplied with the x, I know that this is going to be a horizontal stretch or compression. And if it's negative, it indicates a reflection in the y-axis. Okay? Then we have d. And again, doesn't matter what variable we use, it's where it's located that's important. And you'll notice that d is inside the brackets where the x is. Okay? And so this value here is being either added or subtracted to the value of x. And you'll notice that d still represents your horizontal translation or a shift, so a shift to the left or to the right. And finally, the number that's usually hanging out on the side is the value of c, and that represents your vertical translation or shift up and down. Now, we're going to be looking at exponential functions. And just to remind you quickly, when you have an exponential function, so let's just look back at the previous slide. When you have an exponential function, there's one special little thing that's also in this graph, okay? And that is a horizontal asymptote at y equal to 0. And it doesn't matter whether the graph is increasing or decreasing, you have a horizontal asymptote at y equal to 0. Now, a certain transformation that we're going to be seeing will actually affect the location of your horizontal asymptote. So we're no longer going to be looking at just the base graph. We're going to be looking at some transformed graphs. So essentially what's going to happen here is the only way for the horizontal asymptote to move is if you take the entire graph and you shift it up, or you take the entire graph and you shift it down. So any vertical shift up or down can actually change the location of the horizontal asymptote, and we're going to see that in a few minutes. So looking back at what we have here, note that vertical transformations are outside the brackets and horizontal transformations are inside the brackets. The order of transformations is important. You always want to do the multiplication work first and then the adding and subtraction. So stretch and reflect first and then translate or shift next. And this is the part that we were just talking about with the asymptotes. Make sure you remember that anytime you shift the graph up or down, the horizontal asymptote is going to move with the transformation. Okay, so reminding you of the transformations of any function. So the effects of the variables are still the same no matter what the base function is that you look at. Okay, so the way a, k, d, and c affect the base graph of a quadratic function is the same as the way they affect the base graph of an exponential function, for example. So here's your base function. Notice that we have the letter f here. And if we wanted to look at the same kinds of transformations but with a quadratic function, we replace the f with an exponent of 2, indicating that we're looking at a quadratic function. If we're looking at a root function, we replace the f with the square root sign, indicating that we're looking at a root function. If we're looking at a rational function, we replace the f with a fraction where the independent variable, or the x, is in the denominator of the fraction. So here's our rational functions that we looked at in Unit 2. And then finally we have our exponential functions. And you'll notice that the exponential function is a little bit different. The location of a and c are away from the exponent where the x is. Okay? That's how I know that these two are your vertical transformations. So a vertical stretch or compression or reflection for A, and a vertical shift or up or down for C. Okay? Look at where K and D are located. Because x is in your exponent, when you're looking at exponential functions, K and D also appear in your exponent. Those are your horizontal stretch and compression for K and your reflection as well, and your horizontal shift left or right for D. Both of your horizontal transformations appear in the exponent. Now, the weird part of this equation is that you also have this random letter B, okay? And what this actually represents is the base of your exponential function. So remember that exponential functions can have varying bases. You can have y equals 2 to the exponent x, or you can have y equals 1 over 4 to the exponent x. The actual base of your function can change, and so you can apply different transformations to different base exponential functions, and that's what we're going to be talking about today. So remember that A and C are still your vertical transformations. K and D appear in the exponent, and they represent your horizontal transformations. And the letter B here represents the base of your exponential function.